In this example, we want to evaluate the 6 trigonometric functions at t is equal to pi. Oh, way too thick, so let's erase that. Sorry about that. Let's fix this. So let's evaluate the trigonometric functions at t is equal to pi. So one thing that we need to remember here is we are dealing with the unit circle. And remember that with the unit circle, we have a center at 0, 0, and we have a radius at 1, which means we're going to hit at the following ordered pairs. We're going to hit over here on the x-axis at 1, 0. We're going to hit at the y-axis at 0, 1. We're going to hit at the negative x-axis at negative 1, 0. And we're going to hit at the negative y-axis at 0, negative 1. So let's start off. First of all, we want to make sure that we're comfortable sketching what the angle t is equal to pi looks like in terms of radians. Now remember that if we're on the unit circle, over here, that one complete circle is 2 pi. So we start here at 0, we end here at 2 pi. So if one complete circle is 2 pi, that means half a circle is pi. So the angle pi, we're going to start by sketching the angle in standard form, starts here at 0 and then ends over here at pi. And so this angle would look a little something like this in standard form. Now something to notice is that pi terminates at the ordered pair negative 1, 0. So t is equal to pi is equivalent to saying that we're terminating at the ordered pair negative 1, 0 on the unit circle. So what this does is it gives us our x and our y. Okay, so this is what we need in order for us to figure out what the 6 trigonometric values are. So let's do a quick review of the 6 trigonometric values. First of all, for the sine, excuse me, for this, I do not like that. Let's try that one more time. Once it's a pencil, let's just use this red. Okay, and let's do this. So for the sine of t, the sine, or in this case, the sine of pi, because t is the same thing as saying pi, remember that the sine values are represented by the y values of the ordered pair, and the y value of this ordered pair is 0. The cosine of pi, remember that the cosine values of the ordered pair are the x values, and the x value is negative 1. And for the tangent of pi, the tangent is the y divided by the x, so we have 0 divided by negative 1, which is equal to 0. So we have our sine, our cosine, and our tangent. Now remember, we also have our other trigonometric ratios, so let's take a look at the cosecant of pi. Now the cosecant of pi is the same thing as saying 1 divided by our y value. 1 divided by our y value, which is 0, is the same thing as saying undefined. So we cannot take the cosecant of pi as undefined. We can take it, but the answer is going to be undefined. For the secant of pi, the definition of the secant is 1 divided by x. So that's the same thing as saying 1 divided by negative 1. So the secant of pi is negative 1. For the cotangent of pi, is the same thing as saying our x value divided by our y value. So we have negative 1 divided by 0, which is again 0 in the denominator, means it's undefined. Now notice that we can use the definitions here for sine, cosine, and tangent, but also keep in mind, remember we talked about the idea that these guys are reciprocal values. So once we have sine, in order for us to find cosecant, we can just take the reciprocal of sine, and the reciprocal of 0, remember we could call 0 0 over 1, and the reciprocal of 0 over 1 is 1 over 0. Let's get right there. The reciprocal of cosine of pi is negative 1, which we could call negative 1 over 1, is 1 divided by negative 1, which gives us negative 1. And the reciprocal of tangent, again, if we have 0 over negative 1, the reciprocal of that is the same thing as saying 1 divided by 0, which is undefined. So we could either use the definitions, or we could use the fact that we know the reciprocals of these functions also to help us get the answers.